Okay, so today I'm going to talk about an example of converting a context-free grammar to Chomsky normal form. Okay. So the way that we're going to convert the CFG to a Chomsky normal form is that the first thing we're going to do is remove all epsilon transitions, basically all the rules that can basically create epsilon except for the start variable generating epsilon. We want to remove all the unit rules, which generates a single variable. And we want to basically follow all the rules of Chomsky normal form, which is that only the start variable can generate epsilon, and each variable can generate either two variables, like A can generate AB, or it can only generate one terminal. So you cannot have something like A can generate A, B, C, or A can generate big A, small a. That's not going to happen. Okay. So to go over an example of step one, we have a CFG here. S generates B, B, A, and A generates B, A, B, A, and B generates B, A, and epsilon. So the first thing we're going to do is remove all of the epsilon transitions and basically add it to the start variable. So here, I'm going to take the epsilon and remove the epsilon and add it to the start variable here. But we also have to account for the fact that B used to be able to create epsilon. So because of that fact, if we look at the first rule, or last rule rather, we can see that B used to be able to create BA, and B can epsilon. So then B can now also create A. In the second rule, A can create big A, small a, big A, and either one or both of these B's can become epsilon. So we can have big small a, big B, and big A, or big B, small a. And in the first rule, S can generate BB, and B can epsilon. So we can have just a single B because one of these B's can also by itself epsilon. Okay, so by doing this, we're basically accounting for the fact that B used to be able to epsilon, but now it cannot anymore. So this is our final result. Okay, so for the second step, we want to remove all the unit rules. So our CFG here is A generates BAB, AB, C, B generates BC, ABA, and C generates B and AB. So wherever we see a transition with a single variable, like A generates C and C generates B, we have to copy and paste the entire variable's whole transition to the end of it. So like here in our third rule, C can generate B, but if we remove B, we have to copy and paste the entire thing here over to here. And for A can generate C, now we take the entire C's transition right here and copy it all over to A's transition. And that's our result. The last step is to put the rest of this stuff into Chomsky normal form. So given the CFG BAB, AB, CA, B generates BC, A, B, BCC, and C generates A, B, and C, basically, if there's a variable creating anything other than two variables, so like this one creates more than two variables, or you have no rule in which the variable generates a single terminal, we have to make some other variables to deal with the issue. So for example, here we have this is a problem, this is a problem, and this is a problem. So to deal with this, we have a variable called UAB, which generates UA, which is A and a B, and that can be substituted in for this part to create just a variable that generates two variables here. This one, we cannot have two terminals, so we have UA and UB, which are A and B. And for this one, we cannot have a terminal and a variable, so we make it UC and A. For the second rule here, BCC is a problem because we have three variables, so we have to make it B, UCC, and UCC generates two C's. And that's it. That is the entire result. And that is basically how you do the conversion. So thank you.